Good morning. You joined me on a bad hay fever day, so I apologise for any sniffing that accompanies this video. We are continuing to look at problems involving variable acceleration, and so far we've been looking at using differentiation to relate displacement, velocity and acceleration. And so we've had questions where you've got a formula for displacement and you're asked something about the velocity, so you differentiate the displacement, you find ds by dt, and that's a formula for velocity. Or you're given the velocity and you differentiate it to get the acceleration, dv by dt. It's the same as the acceleration. And today we're going to talk about the opposite, and in fact a few problems that involve both ways. So if you have a formula for acceleration, integrating it gives you a formula for velocity. And if you have a formula for velocity, integrating it gives you a formula for displacement. And that sort of makes sense because with a velocity time graph where you have constant acceleration, the area under the graph gives you the distance travelled. And we know that integration is one way we can find the area under graphs. So let's have a look at some practice questions. Rather than you just sort of watch me go through it, I'm going to today get you to work through these three questions with me, so there'll be quite a bit of pausing, and then you've got a couple to try for yourself. So here we have a question where we are given a formula for velocity, and we're asked to find a distance. So I straight away know that this is an integration problem. To find the distance, I need to integrate 5 minus 3t squared. T is the variable, so we say dt. Now, the answer to that would be a formula for the distance, but it doesn't want a formula for the distance. It wants the distance travelled by the particle in the third second of its motion. Now that's a rather odd bit of wording, isn't it? But the first second, if you're into football, you'll sort of understand this. The first second is between 0 and 1 seconds. And then the second second is between 1 second and 2 seconds. And the third second is between 2 seconds and 3 seconds. So they want us to work out the distance between 2 and 3 seconds. So I'm going to set it out like this. And I'm hoping that this is ringing a bell and you remember doing questions like this with Mr. Godber when he talks about integration. I'm hoping that he and I set things out in relatively the same way. If there's slight differences, then they're not crucial. So I'm going to firstly integrate this expression. Remember, when you integrate, you are increasing the power by 1 and then dividing by the new power. 5 goes to 5t. Remember, it's the opposite of differentiating, so if I was to differentiate 5t, I'd get 5. The reverse is true. So minus 3t squared becomes minus 3t cubed, increase the power by 1, divide by the new power. I'll come back to that in a minute, and plus c. And that's between 2 and 3, so I tend to put the 2 and the 3 there. So I think it's really important. The curly bracket here, this is what I need to integrate. The square brackets are me saying, now I've integrated it, before and after. Now this can be simplified, can't it? Because 3t cubed divided by 3 is just t cubed. And then I'm going to substitute in 3 and I'm going to substitute in 2. And here's how I set this out. This might be slightly different to Mr. Godber, but now the plus c, it's not important, is it, because it's going to disappear in a minute, but I tend to put it in there, but I don't put it in here. So I need to, x isn't my variable, t is my variable, so I need to substitute in t is 3, always the biggest value first, and then take away what you get when t is 2. And this is quite an easy one to substitute in, isn't it? But I do find that this is often where mistakes occur. So let's use this quite easy one to demonstrate a little trick. It's a trick I showed you the other day, actually, in another context. But so I want to work out, trying to get my calculator in picture. I'm just going to slide along to one side. There we go. I want to substitute 3 and 2 into that expression. So here's what I'm going to do. I'm going to substitute 3 in first. So I say 3, I want to store that in x. I showed you that the other day. I'm now going to type in this x instead of t. So I'm going to do 5x minus x hat 3, which is how I do x cubed. And I press equals. And it substitutes it for when x is 3. I'm then going to do the same by substituting in 2. And to do that, I just go back up to the top here and I rewrite that as 2. Store that in x, and when I press the XE button, it reevaluates it. 2. So I get minus 12 minus 2, which is minus 14. Okay, so a couple of issues with negative 14 as an answer. Firstly, negative 14 what? Well, velocity is in meters per second, so that's going to be minus 14 meters. Why is it negative? Well, let's have a quick look at the velocity graph. So I'm going to plot the original function, not the integral, but the original function. I know the area under that graph gives me the distance, and that's why I've used integration. But if I plot that function, I see that between 2 and 3 seconds, the graph is below the x-axis. So the area I've calculated is an area underneath the x-axis. And I know that when you do integration and calculate areas underneath the x-axis, they're going to be negative. So in terms of what's the distance, it's just 14. It's just 14 meters. Okay, so in this question, we're given the acceleration. And we're asked something about velocity, and we're asked to find the value of x. Now, I think this is potentially confusing because t is our variable, x is a displacement. So we're basically given the acceleration, asked something about velocity and something about displacement. So we're going to have to integrate twice. So here's my formula for acceleration. I'm going to ignore the fact they put it in brackets. That's just unnecessary. And I know that velocity is going to be the integral of that. No limits this time. This is just going to give me a formula for velocity, so it's not like the previous example. So remember, increase the power, divide by the new power. 16 would become 16t. I'm very bad here. I should have put dt, reminding me that t is my variable. And this becomes minus 2t squared divided by 2. I increase the power by 1 divided by the new power, plus c, really important to remember plus c. Let's simplify it. Now, that is a formula for v in terms of t, except we've got this constant here. If only we knew a value of t and a value of v, we could work out the constant. Oh, hang on. Bingo. There they are. So I know that when t equals 0, v equals 6. So I'm going to substitute that in. So 6 is 16 times nothing is nothing. Take away nothing squared is nothing, plus c. c is 6. So my final formula for velocity is, that gives me my answer to part A. So I've started with a formula for acceleration and I've turned it into a formula for velocity. Now I want to know a distance because this particle is moving along the x-axis. So x is the distance. So I know we've used s for displacement in the past, so that's why it's potentially confusing. But I know that x, the displacement, is going to be what you get when you integrate the velocity. So I need to integrate this formula. And same as before, I'm going to increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power, That becomes 6t, and I've got a plus c there. Let's do a bit of simplifying. So x is equal to 16 over 2 is 8. Running out of space, but got the same problem I had here. Need to get rid of the c. If only we had a value of x and a value of t that went together. Bingo. So can I get you to substitute in x is 75 and t is 3 and tell me what the value of c is, and then see if you can therefore finish off part B. Okay, so substituting in x for 75 and t for 3, I get this. Simplify the right hand side, take away 81 from both sides, so c is minus 6. So this is my formula for distance or displacement, but the question says what's the value of x when t is 0? So 8 lots of 0 squared, take away 0 cubed divided by 3, plus 6 lots of 0, all of those give you 0, take away 6. You get minus 6. Well done if you got that. So here's a third question. Again, we're given a velocity equals equation, and we're being asked to find a distance. So this is another one where we're going to integrate, and we've got to integrate it between 2 points, but we're not given the t values, the time of those 2 points, which is what we would need. Instead, we're asked to find the 2 points where p is instantaneously at rest. Well, something is at rest if it has no velocity. So what we're looking for is, when does v equal 0? So I'm going to make that equal to 0 and just ask you to use your calculators to solve that for me. Okay, so I use my equation solver, I got 6 and 2.5, just going to check that they're both valid. T is 0 is when everything started, so you couldn't have a negative answer, but that's all good. And it definitely says 2 points, so I've got my 2 points. So what I now want to do is find the distance travelled between t is 2.5 and t is 6. So I'm going to integrate my velocity formula. T is my variable, and I'm going to integrate it between 2.5 and 6. See if you can go through that process and see if you can work out the answer, substituting values in at the end. Try and use the calculator trick that I've shown you. Okay, so this term, increase the power by 1 and divide by the new power, it becomes 6t cubed over 3, and 6 over 3 is 2, so I just skipped a step there. 51t squared over 2, 90t, all nice and easy. Then this is where mistakes often occur, so I used my calculator and set x to 6 and then typed it in as 2x cubed minus 51x squared over 2 plus 90x. I got 54. I then replaced 6 with 2.5, got that. So I've got minus distance again, but we already said, right, that just means it's under the axis. So in terms of the actual distance, that's the distance, and to be strict, we should be rounding to 3 significant figures by default, so that's my final answer. 2 questions to try. One from the mixed exercise on page 193. Given a formula for velocity, you've got to find the value of t when it's instantaneously at rest, so that's when v equals 0, only one value. You've then got to find a distance, so that's integrating, and you're going between t and your answer to a. Those are your 2 values. So that's very much like one of the ones we've already done. And then from exercise 11D on page 190, again, you're given a v equals formula and asked to find when it's at rest, so when does that equal 0? We didn't do this in any of the examples. Find the acceleration when t is 4. Well, that's a formula for velocity. To find acceleration, you need to differentiate and to substitute in t is 4, and then to find distance, you've got to go back to your velocity formula and integrate it. So this is a really good question because it gives you a v equals formula. You differentiate in part B to work out acceleration, and then you integrate in part C to work out distance. Let me know if you have any problems, and then tomorrow we will do some final practice, and that's the end of mechanics.